Finally, something that we can do using all of this division is what I like to call splitting polynomials. So it's a little bit wordy here, but if we have some polynomial p, and I'm always going to label the other one typically as q for like the quotient polynomial, and you'll see why in a second. What we can do is sort of split p up into something times q plus r, and r is also chosen really carefully for a reason. So I've started off with an example. P of x is x cubed plus 4x squared minus 3, and q of x is x squared plus x minus 2. And what I want to do is basically find the corresponding a and r. So you might be asking, why would you ever want to do this? And this is actually stuff that I do pretty regularly with the research that I'm doing. But also it's going to tie in a lot with factoring, which is going to be a very huge theme throughout this chapter. And it'll also give you another tool to factor that you maybe don't know about already. So it just may be a different method that you'll be able to use in the future. So yeah, getting back to my choice of Q and R and why we do this. Something that we've got here, basically, if you look at the way that I wrote this, we have this P of X. I rewrite this, P of X equals AX QX plus RX. So what I'm going to do is divide the left side and the right side by Q of X. And so what we'll get is P of X over Q of X equals, so in this first term here, the Q's will just cancel and you're left with A of X. And we still have to divide the R by Q. And so what we get is exactly the notation of the long division that we've been doing before. So the reason why I called Q, or the quotient polynomial, is because it is the quotient in long division. And the choice of R is because that's the remainder that you get from doing either synthetic or long division. So this is just the same thing. So it's equivalent to long division. So that's what we're going to do. We're going to find the A and the R in long division. Of P over Q. Yeah, so I will just set up my long division. I could also use synthetic division, but I should maybe emphasize here the reason why it's definitely long division or any division. Is because Q is not linear. So we don't get to use the shortcut one for this, but we can set up our long division. So yeah, I'll set up a Q, the denominator goes on the outside. On the inside, I will have my numerator, or my P in this case. So plus 4x squared. I don't have a x, so I'm just going to leave a little gap for it. And then a minus 3. And then this should be a two-step long division. What do I multiply x squared by to cancel with the x cubed? I just need a single x. And so I'm going to distribute the x. X times x squared is x cubed. X times x is x squared. And x times negative 2 would be minus 2x. And subtract. The x cubes cancel by design. 4x squared minus x squared will be 3x squared. 0 minus negative 2x will be positive 2x. And then I can bring down the last term to do the next row. Now I just need a 3 to match those lead coefficients, those lead terms. And so now I'm going to distribute the 3 across. 3x squared plus 3x minus 6. And then I'm going to subtract the whole thing. So first terms cancel. 2x minus 3x is negative x. -3 minus -6 is -3 plus 6, which is plus 3. And so basically what we've got here is if I rewrite all of this, then P over Q equals, so x plus 3 comes out, and then 3 minus x, I just like to rewrite the order because I don't like leading with a negative, over x squared plus x minus 2. And that is what my P over Q is. And so that tells me what my A is and what my R is. A is x plus 3. I don't know why I chose to write with yellow. It's ugly and hard to see, but hopefully you can read that. It's pretty dark yellow. So my A is x plus 3 and my R is 3 minus x. And so yeah, so that would be my answer. A of x is x plus 3. R of x is 3 minus x. Alternatively, we could rewrite this sort of split form as P of x equals, so x plus 3 times, and then my Q, which we know is x squared plus x minus 2, and then plus my R, 3 minus x. And if you look, this would be like if we chose to like go back and check our answer with the rational decomposition, and then we mash it back together by combining over a common denominator, this thing would be the numerator. And so we should hopefully find that if you actually distribute that out and simplify it, we should get P back. So if it's been done correctly, which I'm banking on it has been. So that's a first example. I'll just do one more to kind of lead us into the next chapter. Not the next chapter, the next section. Right, so I've got the next one set up. We've got P of x is this cubic here, and Q of x is x minus 3. And so if I've set this up the way that I want it to, it should be a nice lead in to where we're going and why I'm teaching you this current section. Yeah, so we're just going to follow the same thing before. So if we set up division, AX is the part that comes out. It's not a technical word. And the RX is going to be the remainder, which at least is a little bit more technical. So yeah, we can set up any division of P over Q. In this case, we do have a nice linear setup. This is x minus a for a equals 3. So we can use synthetic, which is nice and fast. So I'm going to put my a on the left, my 3, and then I'm going to list my coefficients. Like I say, I always like to write these guys on the top. X cubed, x squared, x, and the constant. So I've got 1x cubed minus 4x squared plus 2x plus 3. I didn't need the pluses, but I was just in the zone. And if you recall from synthetic division, we add up the first column to get 1, and we multiply. 1 by 3 is 3. Add -4 plus 3 is -1. Multiply 3 by -1 is -3. Add 2 minus 3 is -1. Multiply 3 by -1 is -3. And we're going to add and get 0. Remember I said 0 remainder is very nice. So that's our remainder 0. And so this -1 will be our constant, our x, and our x squared term. And so if you just kind of follow what I said on the left there, the part that comes out is on the left, so that's going to be our a. And the remainder, which is 0, is 0. So I'll just write that out. A of x is x squared minus x minus 1. and r of x is 0. And this is really, really nice because what this means is that p of x equals x squared minus x minus 1 times x minus 3. There's a plus 0, but I don't need to write that. But what that means is that if that remainder is 0, p of x factors, right? We like it when things factor. Factoring is how we find zeros. So that is very handy. So this is a tool that we're going to be able to use when we have high degree polynomials like p and we want to factor it. That's actually what the whole next section is going to be about, factoring these big degree polynomials. As we know all those methods for second degree polynomials and how to find their zeros, we either factor or use a quadratic formula, but we don't have tools like that for higher degree polynomials. So this is how we do it. So the next section is going to be about, well, how do I find that q? And yeah, there is a trick for it. It's just maybe sometimes a little time consuming. But yeah, so that should be everything on this first section. Once you get the hang of synthetic division and long division, it goes pretty smoothly. It just sort of takes a while to explain it.